Hello. Um, okay, so I think in the last week, or I guess where I left it off last time, was that I had decoding all the way implemented. So I had a module like decoded in memory. It's not perfect, but it's enough to get me started, and it's about the right interface so that I can just replace it at some point in the future. Um, this week, I got some basic instantiation and execution working. So I just implemented a basic add function, and so I only have implemented like a few of the kind of structures that I needed. I sandbagged a little bit. I think I got uh, like memories uh, uh, thrown in instantiation as well. But right now it's literally just I have the like local.get instruction and add instructions implemented, and that's it. Um, so so I have basic execution implemented. Um, I can you know at any point I can start writing some more code, and this is executing Zig code. I have a Zig module that I am compiling to WebAssembly and then decoding and executing in my in the program. um, so at any point I can start writing some crazier code in that module, and it'll tell me I haven't implemented whatever instruction. I can go and just implement that. So that's really cool. That's yeah, I'm in a good spot for that to start messing around. Yeah, I mean messing around with it and see what I can do. Um, but I kind of got to that point. I got to execution. I was like, okay, I want to think more about how like the whole system like really fits together, um, and think about it more like as a concrete system. And so I feel good about the distributed store idea. I think beyond that, I want this idea of assemblies, and that naming is TBD. I don't love the name assembly because I feel like the expectation is that it is a low level, you know like instruction format, you know, like WebAssembly, or assembly. Um, but that's the name that was kind of suggested. So I'm rocking with it for the time being. We'll see. Um, but so we have this idea of an assembly. And an assembly is like a static, I guess, graph of how modules should fit together. Um, so a module definitely needs kind of two, how would you say it? It needs two ways of kind of binding. and that is statically and dynamically, as you would expect. So like a static binding would be defined in an assembly, where, I define a module or perhaps another assembly that I want to connect to based on some capability type. So I basically say, in my module, I say, I need a capability that fits this shape, basically. And then the assembly wires those up. So it says, this module needs this capability. This module provides this capability. Add that edge there. And so we create this graph that is an assembly. And I think assemblies should be kind of the unit of isolation. So for example, for like a TCP server, I might want an assembly that is like oh, there's a deer up there. I might want an assembly that is like the platform layers, like TCP stack. And then on top of that, I want a long running, and that TCP stack is itself an assembly. On top of that, I add my own TCP server that is itself an assembly. And then the TCP server, when it receives a connection, it starts a connection handler assembly, and then so on and so forth, right? So yeah, like it is the unit of isolation. I think an assembly should map pretty directly to a store. So like, instead of instantiating individual modules and figuring out where to, which store to put it in, and how to wire it up and so on and so forth, the assembly is what defines that. And I feel pretty good about that. That makes a lot of sense to me. And then the control plane should basically like fill out the basically the graph of assemblies on the machine, on the in the mesh. And then like statically verify, for example, there are no two servers that listen on the same IP and on the same port, right? Like we should be able to statically verify that. Oh, there's already a server that listens there. You you can't register a new one. So I feel good about that. And then from there it's just kind of instantiate the thing when you need it, so on and so forth, right? And then there needs to be like dynamic lookups, I suppose, like dynamic capability retrieval, perhaps you could call it. But basically, like, I need to be able to say at runtime, I need to look up this capability, right? If I have some sort of login system for this TCP server, the user is specified at runtime, right? Like through the connection, through the socket, I am expressing, this is my username, uh, can you look up my password, right? And so, or can you validate this password and then authenticate me? So like that's yeah, like that's that is I mean, you know, that's a very common thing that I think you want to do often. I think that is something that you specify in your assembly, but I think you specify it as a dynamic capability, like dynamic handle or something like that. And then, so what's cool is, since I am building the WebAssembly embedder, I get to decide like what do imports, like how do imports work and all of that. So I can make it so that, you know, you want you know, you want to reference your capabilities and everything, like everything that you define in your module definition. You know, I need this capability and that one, and this dynamic one, and so on and so forth. You just import that stuff. Right? Like that's it. It's strongly typed. It ends up resolving to just function calls. So it should be like really optimized. It should be really easy to instantiate at runtime, and it should overall be like fairly safe. Again, I'm kind of relying pretty heavily on WebAssembly like validation here, but like validation with a, oh, there's another deer, with a capability system, should give me the security posture that I think I want. So, you know, I feel pretty good about that. You know, that's overall good. So like the data plane should overall be fairly simple, I think. It should largely just be instantiating assemblies, and then like that's basically the you know, that's basically the whole data plane, right? And it can be, you know, so long as lookups for assemblies and modules is, you know, fast and distributed, and there's not really a single point of failure. Like it should scale really well, and just overall be very reliable. The So I guess there are two parts to it. The difficulty here is kind of twofold. One, I need that good reliable data lookup on the data plane. But like I feel like distributed KV is something that is a pretty solved problem, and I can, you know, there's a lot of prior art that I can kind of reference when designing something, you know, to make a really solid system. That deer is still over there, but I kind of want to go this way and see if I can't, you know, go around it without bugging it too much. So, I need that replicated lookup, basically fast replicated lookup for the data plane for instantiating assemblies and modules. I also need a system that is a lot more dynamic for like capability lookups, for dynamic capability lookups. Because I think so the like modules and assembly lookups should be pretty easy, because in essence we like the I guess pain, so to speak, is largely around like it's a low volume of changes. They're just kind of big, right? Like you have these modules that are potentially megabytes in size, and assemblies that are certainly smaller, but still, like, it's still like the challenge is replicating the state of the system, I suppose. So replicating a ledger, I suppose, across the system, so that negative lookups are really fast. I guess positive and negative are really fast. Man, it is really muddy today, and I definitely did not wear the right shoes because I thought it would be dry by now. But here we are, I suppose. So positive and negative lookup, I think, like something like memcached is probably a good system to look at. Or like maybe Redis, but I feel like Redis is more control plane than it is data plane. But still probably worth looking at. Yeah, I feel like Redis is more about, has better consistency guarantees. I think, like, yeah, I think that's what I care about. But the harder thing is the dynamic lookups of capabilities, right? That like user lookup at runtime. Like that's a lot harder. And so like, yeah, it's more difficult. And it's I think it's going to require a lot more research to kind of figure out some good ideas and ways of doing that. I don't know them. I don't know how I can, efficiently do that. But that's kind of, I'm leaving it there. I think overall the actual running of things, like the compute side of the data plane, as is always the case, the compute side is easy. The data side is a lot harder. So that's where that's where the data plane is kind of sitting at. On the flip side, the control plane, I have no idea. So I think in essence, I kind of want this idea of like failure zones, which is I think so. I want like two main groups of people to work with the Sapphire system, and that is like platform operators and like application developers, right? So application developers just use the system. They build on some platform. Ideally, the platform implements some, uh, common uh, uh, capabilities that are, common in the ecosystem, so that developers can, excuse me, so that developers can develop their applications in a way that doesn't like, basically that gets rid of vendor lock, right? Um, you develop your applications to some common set of capabilities, and then build on those, and then use composition to get like nicer features, right? Like if I need distributed storage, my distributed storage system still implements the same block device capability that I would be using if I was just interacting with the raw block device. But the storage system, implements replication or erasure coding or, whatever else, right? Um, so that if I want that distributed system, then I can just, slot that in between the actual raw block devices and the and the application module, right? And so in that way, like I as a developer just have to worry about the like plain interfaces that I really care about, maybe store data, interact with the network, what have you. And then, it's really easy to compose up an application and just say, throw TLS in there, because that's just another module that sits in between, it imports and exports a networking capability for a, maybe a networked connection or something like that. Kind of so on and so forth, right? And then a platform operator basically builds out the platform for people to use. So like if this was me working on my own home lab, I would be the operator of my home lab. So like that system would itself be a platform, and perhaps I provide a distributed storage assembly or system, or however it ends up working out to be, that I just wire all of my applications into, and then everything has distributed replicated storage. I don't have to worry about like mounting file systems. I don't have to worry about I don't know how how to implement kernel drivers for the file system or whatever, right? It's just like I have this module, I wire it in between these two things, and then we're off to the races. Or I expose this as the like standard storage capability, right? And then I can effectively write assemblies that are reusable, that just use the standard thing, and then however that is implemented, the application gets, right? However the platform decides to implement that is what the thing gets. So but the platform operator definitely has a lot more knobs and dials that they should be twisting um, to make the whole system kind of fit better with the hardware and with the desired um, with everything, right? So like failure zones are a good example of that, where a failure zone should effectively be the unit of, I guess you could call it isolation, but at the platform level, where like things within this failure zone are pretty fast and consistent, um, but uh, across those zones, it's kind of less consistent. The guarantees are kind of smaller and looser, and but like it's designed in such a way where if a failure zone fails, like it should be able to um, recover that zone somewhere else, basically, right? um, so like that's the unit of like failability, I guess you could call it. um, and that should be defined by uh, the platform operator. So for example, if we're running in a data center and we use top of rack networking, we'd likely want the failure zone to be a rack, so that networking within metals within the rack, within nodes within the rack, should be very fast. It should be easy to get the consistency guarantees we want within a failure zone, because it is, top of rack networking is fast. And then, then like the data plane kind of operates within that failure zone, right? So like I'd say likely we have it set up so that the data plane, like, excuse me, like the data plane lookups for modules and assemblies and capabilities is local to a failure zone. So like we probably only have maybe one or two actual data instances of of uh, you know of any particular module or assembly or whatever within the failure zone. And then if we look something up on a metal that doesn't have it, it should be relatively fast because some other metal within the failure zone does have it. Again, that's like, this is all pretty, I don't know. This is how it's kind of falling in my head right now. And this may change, but this is how I'm thinking about it, right? So, and then like a store could only be instantiated within a failure zone, right? It would have to use some other like embedder connected thing to span failure zones. But of course, all of that would be completely opaque to the code that's running, right? To the application, right? That is a concern for the platform operator. I think developers should probably still know that that's happening, but so that they can, optimize and do things correctly. But yeah, like that is a concern for the platform operator to kind of figure out. And then so back to kind of control plane and data plane. I think that in essence how it should work is each failure zone runs a control plane, and that's how we kind of distribute data across failure zones. And again, so that there isn't a single point of failure. Like as long as we have a failure zone that we can connect to, we can interact with the control plane, and then that control plane kind of replicates itself and does its thing, I guess. So like that's where like it would be important to like specify like how do we do scheduling at in the control plane, right? Or to specify scheduling in my assembly so that the control plane knows when to update this failure zone to maybe have this TCP server running, right? Like that's something that would be defined by the failure zone, I think. And then of course, like the TCP connection that the TCP server starts is something that is something that the TCP server starts, right? It doesn't need to be updated, so to speak, by the control plane. So I feel fine about this architecture, about like failure zones and the separation between control plane and data plane. I think I think it'll be important to what am I thinking of? Like give platform operators like a good mechanism to like really control the data flow between failure zones, because I think it would end up being like really easy to have, I guess, kind of a thundering herd, but just like a really chatty like network stream between like data centers, for example, if any failure zone can talk to any other failure zone. So like maybe we like within a data center somehow offer the ability to mark some number of failure zones as like primaries, and then like everything else is secondary. And so if a secondary failure zone wants to talk to a failure zone in another data center, it has to go through the primary, and then the primary can do whatever rate limiting or back pressuring or whatever it wants to do to make sure those spines aren't just like completely overloaded. Like that seems like a fine idea to me. I feel like we could make something like that work. um, but like, again, like, I don't know the mechanism that, like, for again, I'm in the completely wrong shoes right now, but I don't know the mechanism that control planes failure zones will be operating in. Like, initially I was kind of thinking, okay, I guess we just have a raft cluster per failure zone that's defined by the the platform operator, and then then we have consistent state within the failure zone, that is, you know I guess it would technically be federated, but like in some way distributed and highly available. But like, that's about as far as I got, and even that I feel like is not a great answer, and also doesn't really provide a good, like, how would you say it doesn't provide an answer at all, even for communication between failure zones. So because I feel like I would want almost some sort of like database, sort of thing for the control plane. um but like I don't have a good answer at all, remotely whatsoever, for that. So I've kind of paused like development work. I feel good about the idea of assemblies and like statically defining modules and assemblies so that they can be instantiated at runtime on the data plane. And I feel like that's something that would be fine to start implementing now, and I'm sure I can, and maybe I will start messing around with it, with with like statically defining these things. um but it is kind of difficult because I'm really big on like sandbagging and like um how would you say, like doing the grunt work of like defining the system ahead of time, and then once the system is defined, it's basically just an exercise of implementation, which is like not not crazy. um but like without knowing like the interface that I need to support this sort of like hierarchical, um like distributed system, like I think it would be very easy to implement things in a very like a very bad way. I think it'd be very easy to kind of implement a system that just like makes building it distributed really hard. Right? I think instantiating and assembly is something that is a small enough unit within the system that I could implement it now, but like literally anything past that, like module lookup, for example, I don't really want to implement now because I don't know the interface that I'll want to interact with module lookup with, right? So I've kind of paused development for a little bit, and I'm starting to like read research papers. So I just got through MapReduce, and I'm looking at GFS. I'm going through some MIT courses reading list. I think it's a graduate level distributed systems course. I'm just going through the reading list to as a starting point for getting some distributed systems kind of thinking under my belt. But like, I'm hoping that that's going to kind of give me the vocabulary and the kind of way of thinking about distributed systems so that I can design the interface in such a way that regardless of how, what the production implementation ends up looking like, it will fit within the system pretty well, right? That's the idea. That's the intention. And then so that it's like, so that it's effectively like what I have now with modules, where it's like, yeah, the module decoding right now is like pretty bad, and so is like the store. I'm sure I'll nuke both of those, just like completely get rid of all the code, and then start implementing, something better. I know how I want the decoder to look. I'm not quite sure about the store, but like we'll get there when we get there. I think again that'll require a little bit of distributed systems thinking to figure out like the correct answer for them. But like certainly the decoder is something where it's like it will be really easy to swap out the implementation because the interface that I interact with it in is very small, very to the point, and I don't know, like overall just like easy to interact with. So when I do go and swap it out, like it's not something that leaks, is I guess what I'm trying to say. I'm trying to design interfaces that just don't leak. So that I can do that, so that I can implement something and then make it really easy to swap out in the future. And I guess the entire like Sapphire system is a system of like designing systems that don't, or designing interfaces that don't leak, right? That's really the problem statement that I'm trying to kind of solve here, is that like it is so unbelievably common for programmatic interfaces to leak. And I think that's a lot of the, that's a lot of where like issues are had, and where like you get weird bugs and weird behavior, and a lot of the issues that I have with like my home lab, like with Ceph and with Kubernetes, is like the issue is that the abstractions that they're trying to provide leak. So I need to, design around the implementation of the abstraction rather than the abstraction itself, right? And so the hypothesis, I suppose, is if I can sit here and design a system where no interface leaks, no abstraction leaks, where, we don't get any, how do you say it, like at every point in the system, I am designing around the abstraction that I'm designing around, right? I'm designing around the block device interface or the TCP socket interface or the whatever other interface, the user interface or whatever, right? I don't care how that thing is actually implemented. I care about the interface itself, right? If I think if I can do that right, then the system will just overall be so much more reliable. It'll be so much more easy to develop for. It'll be so much more, quick to iterate on. That's I think really the hypothesis that I'm uh, uh, kind of exploring right now. You know, we'll see. I have a lot of research to read, but I think if it lands the way that it's kind of shaping up to be in my mind, I think it'll be like I've talked at length with a coworker about developing new systems, I suppose. And he talks a lot about like it's very important for new things to be compatible with the old things so that the on-ramp is very easy. And that's certainly true in a lot of cases, but it's not absolutely true. Right? I think Swift is a really good example of that, where Swift was, I believe in feature parity with Objective-C, but added some other, added a lot of like niceties for developing on like the Apple platform. And then, it's just over time, it's like we stopped building APIs for Objective-C and start building them for Swift. And then it's like, okay, you can still use Objective-C, but like, you really should just be using Swift, right? And that kind of transition is made a lot easier because you can have, you can simultaneously have Objective-C and Swift in the same project. But like on the flip side, I feel like the world of the web is very indicative that like if something is really just that good, like people will make an active effort to switch over to it, right? We have these cycles of like put everything on the server render everything, and then the the flip side of that, which is put everything on the client and then client render everything. And then you have the kind of in between, which is server render what you can and then use hydration and blah, 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 right? And we go through these cycles like every, I feel like a full cycle is probably around a decade. I if I'm being honest, I don't really know where we are. I feel like we're still in hydration right now. So like an in between. But I feel like more and more is moving to the server right now. And it's like, like newer and newer frameworks are like, Astro is like, it's actually really good. It's like, server render everything that you can, and then client render whatever you need to. Make that boundary really obvious, and then don't do hydration, right? Like that's a really pleasant framework to work with, and it, it's good enough that it's like I want to migrate whatever thing that I'm working on to Astro. You know what I mean? And so I feel like, especially if there's a system where it's like, yeah, you get, for example, retries, like doing retries at every single failure boundary of your system is like truly unbelievable. Like that is something that is so abysmal to work with. It's just like, like it's just awful. But like if I can say, hey, I can like automatically insert retries into your system without you really, really even needing to know that it's happening, but like giving you the space to interact with it in such a way that you can disable retries, or you can add your own retry logic, or you can do whatever. Like I feel like that by itself is like, okay, all of a sudden we can just like automatically have a more reliable system. Of course, you're gonna have to rebuild, like it is a completely different platform, right? But it is that new platform that allows you to really do that thing, right? And so, and on top of that, you like the development of your application should be significantly simpler, and it should be a lot more homogeneous, and you should be able to care a lot less about encryption, for example. Like we should be able to provide a TLS module where you just slot it in between your TCP connection, right? And then it's you have TLS, right? It is that like encapsulation and composition system that is opaque to you, but makes it really easy to build and reuse these kinds of systems, right? And then you could have whatever group does TLS, the W3C or whoever it is, implement a reference implementation of TLS using the standard connection capabilities in the system. And then it's like, yeah, here's a new version of TLS. You can start using it today, right? It's not like, oh, we have to go through years and years of waiting for like Google and I don't know, Node and whoever else to implement the new version of TLS and all of the things. It's like, no, we can, we can have it today. Right? You just add the new module to your system, and then you have it. Right? Like, that's the promise of Sapphire in my mind. It should just kind of overall make building systems, building reliable systems quicker and easier, right? I think that's overall the like the promise of Sapphire in my mind. But again, gotta read a lot of research, I think. And we'll see. We'll certainly see how things play out. But I think certainly on the data plane, it's shaping up to support that really easily. And I think the piece that needs to fall into place is the control plane. And if that, if I'm able to get something that does what I want it to in the way that I want it to, like, I think that should be really, really great. I think it'll be a really, really great system. Yeah, I think that's about all of my my thoughts for now. So I'll see you later. Bye.